Part 3. Those of you who were looking at how many atoms of hydrogen are in 2C6H12O6, A2B12C14, D24. Number 2, how many atoms of carbon are in 2C6H12O6? A2B12C14, D24. And the third question, the law of conservation of mass says that matter is neither created or. Okay, take a couple seconds to answer each of those questions. Objectives. Students will be able to define the law of conservation of mass and also apply the law of conservation of mass to balancing chemical equations. In high school, you're going to learn to balance equations more. But for now, you have to at least understand that the equation, according to the law of the universe, must be balanced. How do you know if an equation is balanced? Check the number of atoms on each element on both sides of the equation, the reactants and the products. And if the number of atoms of each element is the same, then the equation is balanced. How can I tell how many atoms of each element are? Coefficient, the big number written in front of a chemical formula that tells you how many molecules of that substance there are. For example, 5 H2Os, 5 molecules of water. The subscript, the little number at the end of the element, tells you how many atoms of each element there are. H2O, you have 2 atoms of hydrogen in each molecule of H2O. How can I tell how many atoms of each element there are? Well, the coefficient times the subscript tells you how many total atoms of that element are present. For example, 5 H2Os, there are 10 atoms of hydrogen and 5 atoms of oxygen. Now, if there's no coefficient, then there's only 1 molecule of that substance. Let's see it in action. 2 Fe2O3s plus 3 carbons produces 4 iron and 3 carbon dioxides. Fe is 4, that's the iron, and on the other side, because you have the 2 times the 2, and that's on the reactant side, and on the product side, it's 4 iron by itself and 3 CO2s. So you've got the iron on both sides balanced, the oxygen on both sides balanced, and the carbon on both sides balanced. Now here's another example. 2 AgNO3 plus copper carbon oxide produces Ag2CO3 plus CuNO2 times 3. So you try it. You've got hydrogen 2 plus oxygen 2 becomes H2O. Is that balanced? 2 H2s is now 4 hydrogens plus O2s produces 2 H2Os, 2 molecules of water. And the first one is unbalanced, and the second one is balanced. And we saw that when we did the beans experiment the other day. Now you determine if each of these equations are balanced or unbalanced. You take the time to figure it out, and then we'll come back to you. Pause, figure it out, and do it on Edpuzzle. Okay? Is that what you got?